Hello, this is Scott Baceno here at Qualcomm HQ in San Diego, where they're hosting a 5G/IoT day. Earlier on today, we had a presentation from John Smee, who's the R&D lead for 5G at Qualcomm. So John, why don't you start by talking us through your presentation?
Sure. This morning I was explaining from Qualcomm all the investments we made in 2G, 3G, 4G. How did they translate into foundational aspects that we incorporated into our broader 5G vision? If we look at the core research we've been doing for many, many years, as Qualcomm, we like to say we're in the G business. So this transition from 4G to 5G was exactly what, these are the sort of transitions we like, because it's the opportunity to bring more foundational ideas together in creative ways to solve new problems. So for 5G, one of the exciting problems we were trying to solve was we wanted to create a system that could serve three relative disparate use cases. So think of mobile broadband, the stuff we're already doing today on 4G LTE. So connected smartphones, connected laptops. Then think of massive numbers of low power devices, more numbers that are already connected today. And think of mission critical, high reliability, low latency communications. How could we design a system that could efficiently serve all these three? So I was explaining the designs, the core foundational inventions we had, not only from 3G and 4G, but even in the 5G era. How do we bring all these ideas together, prototype them, design them, test them, bring them to standards, and enable us to then launch projects in 2019 from a commercial standpoint? So it's that end-to-end innovation when we go from design and research, long-term academic aspects, and telegraphing that into 5G, not only in release 15, the devices that are already in stores, but where do we see 5G in the next 10 years? Where do we see 6G after that?
So we're already talking about 6G?
Well, not really, but at the same time, one of the things we like to do is explain that, hey, the very next release of 5G is not 6G. So it's not like, oh, 5G happened, so next year, when's my 6G phone? I'm gonna wait. No, it's at least a decade away, and it's because of that aspect that 5G itself is very flexible. It can evolve in many different ways. It already supports licensed spectrum, unlicensed spectrum, shared spectrum. It supports low bands, medium frequency bands like 3.5 gigahertz, 4 gigahertz. It supports unlicensed spectrum and millimeter wave bands. So it has a huge amount of spectrum, a huge amount of use cases, whether it's vehicles or factories. So there's so many different parts of 5G. One of the challenges is making sure that from a commercial standpoint, we can address them in the right order. And that from a research standpoint, when I look at how our teams are aligned, making sure that pipeline of innovation is well aligned to not only the near-term opportunities and the intermediate opportunities, but also that more foundational long-term aspect.
So from your point of view, it must be pretty challenging with all these different technologies and use cases for 5G. Why don't you talk us through how you reconcile that?
If we look at the challenge of connecting these different types of use cases and different type of scenarios, that absolutely is the challenge. Like you could drown in the complexity of it if you didn't do it in the right way. And so one of our core design principles was making sure we had a scalable framework from the start. So one of the exciting things was we were absolutely talking to the automotive industry, talking to the industrial industry, looking across different types of spectrums, different latencies, understanding where AR and VR and XR are heading. So we had to incorporate all of those things into our core design so that the first instantiation of 5G from a standardization standpoint had the right hooks into it, that it could evolve in what we call a forward compatible way. So those investments that the ecosystem's making in deploying 5G, we wanted to make sure that there's going to be forward compatible. The future investments are going to enable more use cases, but in a way that the old use cases are also supported. So that was the challenge we imposed on ourselves as research engineers, saying, hey, we better get this right. It's a big responsibility because we're trying to do a lot more. We're not just trying to say, hey, let's make something a little bit better than LTE. Let's have better video downloads. It was much more expansive in scope. So we had to be a little bit more disciplined in how we looked at the ideas and how we brought the ideas together.
So next year is when we're expecting a lot of this stuff to take off. Perhaps you could finish by identifying a particular use case which will illustrate that 5G is being a success.
I would recommend you keep your eye out for how does factory transform how industry is able to use cellular and how consumers are evolving not only in the smartphone era, but in, for example, the extended reality area. So I would say look at the factory of the future. Understand, when do industries say, you know what, we want to do this over wireless. We want to bring 5G to our workforce to make them more productive. We want to educate people in a more seamless way. The communication's getting to them. And then all of a sudden you're saying, that would be great if the glasses you were wearing were connected to the 5G edge cloud. Then all of a sudden the sort of information you would have
heads-up display.
Heads up, it would be so much more intuitive. It would be done in a way that's seamless from a user experience standpoint and is contextually relevant.
Okay, thanks a lot, John. That was very interesting.
You're welcome. Thank you.